Prelim paper for Nanyang Primary, paper 2. So calculators will be allowed for paper 2. Let's look at question 1. A lamp is 2 kg heavier than a vase. The total mass of 5 such lamps is kg. Find the mass of the vase in terms of K. Okay, so one lamp is 2 kg heavier than a vase, and 5 lamps is kg. So one lamp will be K divided by 5. Okay, because they said 5 lamps is kg. So we find one lamp first. And then when we compare the lamp and the vase. So the vase, according to the first sentence, the lamp is heavier than the vase. So the vase will be lighter. Lighter we minus. Okay, so we take the mass of the lamp and minus 2 kg. So this is the answer. Bracket the whole thing. Okay, because it's separated by a minus sign, so we are trying to say that the whole thing is kg, not just the 2. Question 2. Table shows how much a worker is paid each day. For the first hour is $75. Every additional hour is $40. So if a worker works for 4 hours, there is this additional $10 that will be paid. So Mr. Morris was paid $325 for a day's work. How many hours did he work? Okay, so first let's group the 4 hours first in a group of 4 hours. Okay, there is a difference between the first 4 hours and the subsequent 4 hours, because in the very first 4 hours, right, the first hour is counted as 75. Only the first group of 4 hours. So let's look at the first 4 hours. So we have 75 for the first hour. Then we have 3 times of 40 for the other 3. Okay, then if you have 4 hours, you will get extra 10. So you calculate this out, you will get 205. Okay, this is for the first 4 hours. For the subsequent 4 hours, right, it will be at a different rate. So subsequent 4 hours, it will be at 40 times 4 times 40, then plus the extra 10 for every 4 hours. So this is 170. Okay, so it'll be 205 and then 170, and so on. So he gets $225. So let's take away the first 4 hours first. 325 minus 205. Let's see how much is left. This is 120. Okay, 120 is definitely less than 4 hours for the next set of 4 hours. So we know that he completed at least 4 hours because 205 is the first 4 hours. So what about 120? 120, how many hours is that? So we take 120 divided by 40 because it's 40 for every hour. This will give us 3 hours. So the total time taken will be 4 hours plus 3 hours. Total 7 hours. Okay, so the 205 is the first 4 hours, and then 120 is for the next 3 hours. Question 3. X, Y, and Z are 2-digit numbers. The average of X, Y, and Z is 56. X is 2/3 of Y. Find the smallest possible value of X. Okay, so first we are given the average. So you can find total, which is 56 times 3. Okay, you take the average, multiply by the 3 numbers. Then I have a total of 168. Then they also tell us that X is 2/3 of Y. So I write down the ratio, X to Y is 2 to 3. if you want the smallest possible value of x, right, it means that you would want the smallest possible sum of x and y. So I will treat my z as the biggest possible value, which is 99. So I'll take 168 minus 99, which is 69. And this will be the smallest possible value for x and y, which is 5 units. Okay, but now we know that x and y is actually 2 units, 3 units, right? So the sum of x and y must be a multiple of 5. Okay, so the smallest sum of x and y will be, okay, at this point, do we go 65 or do we go 70? Now remember this 69, right, is the lowest it can go because the biggest value z can be is 99. So the lowest sum we can go is 69. Nothing lower than that. Okay, because if you have anything lower than that, then z will become a 3-digit number, which is not supposed to be, because all the numbers are supposed to be 2-digit numbers. So 69, we have to go higher because 69 is the lowest it can go. So to get multiple of 5, we use 70. So to find x, we will take 70. So 5 units is 70. So 1 unit, 70 divided by 5. This is 70. Okay, which is 14. Then 2 units, which is x, will be 28. Okay, so this is the smallest possible value. Question 4, what is the price of the handphone after adding 8% GST? Now, before GST is $809. So anything before GST, we'll treat it as 100%. Okay, then we find 1%, and we find price of the handphone after adding GST is 108%. So what we can do is, instead of finding just 1%, we need to divide by 100, right? So we'll take 890 divide by 100 times 108. Okay, to get the answer straight away. So this is the answer. After GST is $961.20. Question 5. Figure below, ABCD is a square, CEFG is a rectangle. You have 203 degrees. Find BCE, the angle marked out over here. Okay, so you see this 203 degrees, right? The whole thing is 360. So let's find DCG first. $360 minus 203. 157. This whole thing here is 157. Now, I want to find angle DCE first. By taking away, since this is a rectangle, this ECG will be 90 degrees. Okay, so angle DCE is 157 minus 90. So this is 67. Then to find BCE, which is what we want, BCD is right angle, 90 degrees, so 90 degrees minus 67 degrees. All right, so answer 23 degrees. question 6. Okay, this question a bit challenging for a 3-mark question. All right, so we have a parallelogram over here. By joining dots on the grid with straight lines, draw square ADEF. We already have A, we already have D. Okay, so you need to draw a square using AD. Find 2 more points, E and F. And it must not overlap with this parallelogram. Okay, so AD is one side. You need to draw another side that is perpendicular to AD. Okay, how do you draw perpendicular lines? Okay, let me use another color. Okay, A to D, 2 to the right, 4 down. Right. So to draw a perpendicular line, we do the opposite. So we go, instead of 2 to the right, we go 2 down. So you just need to follow the dimensions like 2 and 4. Okay. So when you go down by 2. When you go to the left, you go down by go to the left by 4. So it's always either like horizontal or vertical. So here. Okay, use a ruler to draw this. Now draw the same parallel lines. So parallel means 2 to the right, 4 down. We do the same. 2 to the right, 4 down. 1, 2, 3, 4. 4 here. And you connect this. Okay, so this is for part A. Then for part B, by joining dots on the grid with straight lines, draw trapezium CDGH. Okay, any points given? Yes, C and D is given. Okay, wait, sorry, we need to label this A, D, E, F. So this is E, this is F. Make sure you go in sequence, okay, not the other way. If they say A, D, E, F, so you have A, D, then E first, and then F. Okay, go in like either clockwise or anti-clockwise, but must be in sequence. Okay, trapezium CDGH. So we have CD, we need to find out where is GH. CD is twice of GH. GH parallel to CD and DG equals to GH. Trapezium CDGH must not overlap with the parallelogram. Okay, so first, CD, GH is parallel to CD. Okay, so CD is here. GH will have to be in the same direction. Okay, it can be like here, it can be like here, it can be here, but you know what I mean, right? So it has to be parallel to CD. CD is twice of GH. So GH is only half of CD. So it should only be like this long for GH. DG is parallel to DG is equal to GH. So DG is also the same length. DG. Okay, let's try and plot DG first. So DG must be cutting across the grids like that, like cut across one square and then cut across another square. So we can do this 1, 2. Okay, so this is G. DG same length as GH. Okay, so when you draw GH, it has to be the same length as the yellow one, the highlighted in yellow. This. Okay, so this is H. Now you just connect C to H. Okay, please use a ruler. It's a bit hard for me to do it here. All right, so that is your part B. Trapezium C, D, G, H. Again, just check that the letters go in order. Then for part C, find the ratio of the area of parallelogram A, B, C, D to the area of A, D, E, F to the area of this trapezium. Express your answer in the simplest form. Okay, so before I find the ratio, right? Let's find the area of each of the figures, each of the quadrilaterals. For the parallelogram, okay, let me use a different color. For the parallelogram, now take note that you shouldn't be using the diagonals, you should be using the horizontals and verticals. So, okay, let me erase this first. So you see this, the parallelogram can be cut into half. So I'll be finding the area of two of these triangles. Can you see that I'm trying to use half times base times height. Okay, so the area of the parallelogram is half times, sorry, the triangle here. So the bottom is 6, so half times 6. The height is 4, half times 6 times 4, which is 12. Then you want twice of that to find the parallelogram. So 24 for the parallelogram. Okay, then let's look at the square. For the square, a bit trickier. So you can find this, or you can split it this way. I mean, this is not the only way to split the square, using horizontal and vertical lines. Okay, if you do this, I'll just highlight and so you can follow along. So this triangle here is half times 1, 2, 3, 4. Base is 4, height is 2. So this is 4. Then there's actually 4 of that. So 4 times 4. Then the square, which is here, will be 2 times 2. So that whole square will be 16 plus 4, 20. Okay, next. Trapezium. Trapezium, we can split it this way. Okay, so trapezium, we have two triangles, half times 4 times 4, which is 8. The top one, and then the bottom one, half times 4 times 2. Which is 4. So total 12. Now we can have the ratio. Okay, let's write down the ratio. Parallelogram to the square to the trapezium. Parallelogram is 24. Square is 20. Trapezium 12. Simplify, divide by 4. 6, 5, 3. Okay, so this is the answer. This is how we get the answer. A bit lengthy for 1 mark question for part C. All right, next question. Question 7. At a bakery, Mrs. Tan bought 9 chicken puffs and Mrs. Lim bought 5 beef puffs. They spent the same amount of money buying these puffs. Each beef puff costs $1.20 more than each chicken puff. How much money did Mrs. Tan and Mrs. Lim spend altogether? Okay, so they spend the same amount of money. Mrs. Tan bought 9 chicken puffs, Mrs. Lim bought 5 beef puffs. So if they spend the same amount of money means that they must cost the same, right? So the 9 chicken puffs is actually the same as 5 beef puffs. Next, they said that 1 beef puff costs $1.20 more than a chicken puff. So 1 B is actually 1 chicken puff plus $1.20, so 1.2. Now, what I want to do here is I want to make either the beef or the chicken puffs the same. So let's make the beef puffs the same. I want to change this to same as this, 5. So to do that, I have to times 5. So by 5 beef puffs is actually the same as 5 chicken puffs plus $6. Okay, multiply by 5 or so. Right, so now I have this. Oops, I have this. They're actually the same thing. So this over here is actually the same as 9 chicken puffs. Okay, so I can say 9 chicken puffs is actually 5 chicken puffs plus $6. So if you look at this equation, right, what is the $6? $6 is the cost of how many chicken puffs? So for this to make sense, this has to be 4 chicken puffs. Okay, because 5 chicken puffs plus 4 more to give you 9. So 4 chicken puffs is $6. 1 chicken puff is $1.50. A question, how much did Mrs. Tan and Mrs. Lim spend altogether? They spend the same amount of money, right? So with chicken puffs, you can just find what Mrs. Tan bought, which is 9. 9 chicken puffs. So since this is what she spent and they actually spend the same amount of money, the amount spent altogether, you can just times 2. So answer $27. Question 8. Janet, Samuel, and Farhana used the same number of ice cream sticks to make some popsicles. Janet had 3/7 of her ice cream sticks left. Samuel had 1/4 of his ice cream sticks left. Farhana had 7/9 of her ice cream sticks left. They had a total of 1,265 left. How many ice cream sticks did each of them use to make popsicles? Okay, so the question has given us the fraction of what each of them is left with. But if you read the first sentence, they actually said that the amount that is being used is the same. Use the same amount. So what we should be focusing on is the amount used, like the fraction used by each of them. So if Janet had 3/7 left, then the amount used will be 4/7. Okay, so 4/7 of J is equal to how much is used for Samuel? Samuel had 1/4 left. So he actually used 3/4. Then also for Farhana, so Farhana had 7/9 left. So it means that she used 2/9. Okay, so can you see that I'm actually focusing on the amount that is being used, not the fraction that is given in the question, because the question gave what's left, right? But they say the amount used is the same. So I'm using the amount used. So this is equivalent proportion. In equivalent proportion, we'll make numerator the same. So we are saying like 4 units of John equals to 3 units of Samuel equals to 2 units of Farhana. We want to make them all equivalent. So we change 4, 3, and 2, common multiple 12. And change to 12, multiply the bottom also, times 3, so this is 21. 12, you times 4, so this is 16, times 6, this is 54. So what we can see is that 12 units of John equals to 12 units of Samuel equals to 12 units of Farhana. And John has a total of 21 units, Samuel 16, Farhana total 54 units. So the ratio of what they actually have at first will follow the denominator. Okay, so this is what they have at first. Question said that they had 1265 left. Now, 1265 is not the total of these units, but the amount left. Okay, back to the step above. What is 12? You know, when we said that all these fractions, they are equivalent, right? We are talking about the amount used. Okay, so all these are used. So the amount left for each of them, for John, no, Janet, 21 units minus 12. For Samuel, 16 units minus 12. So for each of them, I will minus 12 to find what they are left with, like how many units are left. Now I'm going to add all of these up. That will give us 1265. $55 units is 1265. 1 unit is 23. How many ice cream sticks did each of them use? Okay, so remember they use the same, right? So 12 units is what we want. 276 ice cream sticks. They want each of them, so don't need to times 3, just 12 units will do. Okay, now moving on, question 9. A group of 5 girls booked a computer for 2 hours. They took turns to work on the computer for their project. At any one time, only 3 girls worked on the computer. So on average, how long did each of them work on the computer? Give your answer in hours and minutes. Okay, so you have 5 girls. Okay, let's say that's 1, 2, 3, 4, 5. The total time given is 2 hours. Okay, let's change to minutes first. 120 minutes, they are supposed to share that 120 minutes, right? Okay, so to make it easier, what happens if there's only one computer? How are they going to share that time amongst the 5 of them? So if only one is allowed at any one time, so we look at only one computer. Like if there's only one available, then the time for each girl is actually 120 minutes divided by 5, right? Because they have to share the time equally. So each person gets a total time of 24 minutes. However, if now they don't just get like one computer, they have like 3. Oh, okay. Sorry, they said 3 girls work on the computer. Okay, let's assume that there's like 3 computers, okay? So if there are 3 computers, 3 spots for them to work at any one time, right? If 3 girls at any one time then the time for each girl. So imagine initially you only have one, right? So only one person can do at any one time, which is like 24 minutes each. And the rest of the time, they will be spending waiting, right? They will be waiting for their turn. So if the chance of using a computer is now tripled, then instead of waiting for the rest of the time, the amount of time that they are actually spending on the computer will be tripled as well. So we times 3, which is 72 minutes, and convert to hour minute, 1 hour 12 minutes. Okay, so 1 hour 12 minutes for each of them. Question 10. At 8 a.m., Patrick and John traveled from A to B constant speeds. They traveled along the same route. Patrick traveled at 25 km per hour faster than John. When Patrick reached the midpoint between A and B, John was 30 km away from the midpoint. What time did Patrick reach town B? Okay, let's draw this out. You have A, B. Patrick is faster than John, okay. So let's say Patrick has traveled this much. Oh, sorry, okay. So the question says when Patrick reached the midpoint here. Okay, this is Patrick. John, who is slower, was 30 km away from the midpoint. So this is John. Be something like that. He is slower, so is behind the midpoint. This is 30 km. Okay, so you have a diagram like that. They didn't give us Peter's speed, no, John's speed, but they did give us the difference in the speed. This difference in the speed means that in 1 hour, Patrick actually can travel 25 km more than John. Okay, so we call that the difference in the distance in 1 hour. The difference in the distance that they travel in 1 hour will be 25 km. So the difference that we're looking at is not 25 km, but 30 km. So how much time is that? So time taken for a difference of 30 km would be 30 divided by 25, which is 1 1/5. This is in hours. So take note for hours, for time, I'll just leave it as a mixed number. It is not. If you write 1.2, the careless thing that most students do is like they think 1.2 is 1 hour 20 minutes. Okay, but it's not. So 1 1/5 hour is the time taken. They're asking what time did Patrick reach town B. Now, if Patrick took 1 1/5 hour for this, right? To reach town B, he will take twice the time. So 1 1/5 times 2 equals to 2 2/5. And if we convert this 2 2/5 hour into minutes, into hour minute, because we want to find the time, right? Which means I need the timeline. So this is 2 hours, and 2/5 of an hour is 24 minutes. So to change the hour to minute times 60, okay? So 2/5 times 60 is 24. So timeline, 2 hours 24 minutes later will be 10:24. So answer 1024 in 24-hour clock. Question 11. A 13 cm cubicle container was filled with water to a height of 11 cm. Okay, find the volume of water. Now, this is 13 as well because it's cubicle container. Height of 11, so this is 11. So to find volume, volume of water, 13 times 13 times 11. Okay, 1859. Write your units, 1859 cubic meter cm. Then part B, tank Y was filled with some water at first as shown below. All the water from the cubicle container here was poured into this tank Y. At the end, tank Y was 5/7 filled with water. Find the height of water in tank Y at first. Okay, so now we're talking about height, water level. If tank Y was 5/7 filled, what is the height of the water in the end? 5/7 of 28 cm. So water level in the end will be 5/7 of 28, which is 20 cm. Okay, so water in the end is 20 cm. You're supposed to remove the water from this tank, this cubicle container. Yeah, it's supposed to remove some water, but how will it affect the height, the volume added? So remember we found the volume added 1859. 1859 divided by the base area will give you the increase in water level when we add the water. So increase in water level, 1859 divided by base area, which is divided by 25, divided by 22. 3.36. So water level in the end is this, and then you have to take away the increase due to the water being poured from the container, the cubicle container. Then you can find the water level at first. Okay, so 20 minus 3.38, 16.62. Okay, height, so just cm. So alternatively, you can actually find the volume of the water in the end and then minus the volume of water added. And using that new volume, you divide by the base area. Okay, that's the other way. So this way, we are using height to help us find. Question 12, Shu Xing had a rectangular box measuring 32 by 12 by 24 cm. She painted all the faces of the block. Then she cut the block into 2 cm cubes. So how many cubes did she cut from the block? Now, okay, how we do this is sometimes it has a remainder, right? But in this case, there will not be because 2 cm cubes, each side will fit nicely all the 2 cm cubes. But this is what I'll do. I'll take 32 divided by 2, 12 divided by 2, and 24 divided by 2. So how many can you fit along the length? 32 divided by 2, which is 16. How many can you fit along the breadth? 12 cm. So 12 divided by 2 is 6. And how high can you go? So 24 divided by 2, which is 12 cubes high. So total, how many cubes? Do not add, but you multiply. 16 times 6 times 12. Okay, so 1152 cubes is what you can fit. How many of these 2 cm cubes had none of the faces painted? Okay, so if you don't want any faces to be painted, right, then we're talking about the cubes that are actually on the inside. Okay, the cubes that are not exposed to the outside. There's no surface area that you can see. So how do you find the cubes inside? You know, there's always like one, there will always be like one cube at the corner, right? And then one cube at the corner. So if you want to find on the inside, right? And I'm just talking about the length part. You want to find how many cubes here? Since you can fit 16 cubes, as we have found, then you minus away 2 to find like the number of cubes in between. Now, same for the breadth. You have to minus the 2. Along the breadth, there are 6 cubes. You have to minus the 2 at the corners, because the 2 at the corners will be exposed. It's on the outer layer. Then the height, 12 cubes maximum. Take away the top and the bottom one, because those 2 layers shouldn't be counted since they are also exposed. Then these are the number of cubes that are fitting along the length, breadth, and height on the inside. Okay, the inner cubes. Then we multiply all these numbers. 14, 4, and 10. So answer 560. Okay, question 13. Some children sold cards for a fundraising event. Each small card was sold at $5. Each big card was sold at $8. So the table shows the number of cards sold by the 3 of the children. So which of the 3 children above collected the most money? Okay, let's calculate for each of them. So for Janice, 12 small cards, each small is $5. So 12 times 5. 7 big cards, so 7 times 8. This will give us 116. Deepa, 7 small and 9 big. This will give us 107. Then seeing 6 small and 10 big. This is 110. So who collected the most? It will be Janice. How much? 116. B, Bradley sold as many as Deepa, but collected $15 less than her. So how many small cards did Bradley sell? Okay, compare it to Deepa. Deepa has 7 small plus 9 big. So total 16 cards. Bradley also sold 16 cards, but he collected less. So what do you know? Did he collect like more? I mean, did he sell more of the small or more of big compared to Deepa? So since he collected less, so he must have sold more of the small cards, right? So not so many big cards. Not so many big cards. More of them are small. So what we do is we do an exchange. Okay, we need to exchange from big to small to make the small greater. So every one exchange from big to small is 8 minus $5. there is a decrease of $3. There's a decrease of $3, but Bradley didn't just collect $3 less, right? But it's $15 less. So the number of exchanges will be 15 divided by 3, which is 5. So to get Bradley's number of cards, there are 9. We start off with 9 big. There are actually 5 times you exchange. So the number of small will be 5 more. Okay, so 7 plus 5. Answer 12. Okay, question 14. In class 60, when only one girl stands up and the rest of the children are sitting down, the number of boys sitting down was half the girls sitting down. When only one boy stands up and the rest of them sitting down, the ratio of the girls sitting down to the boys sitting down was 9:4. So what is the total number of children in class 60? Okay, there are 2 different scenarios. The first scenario, one girl stands up. Okay. One girl stands. Then the boy is half of the girls. So those who are sitting, B to G, boys half of the girls, so 1 to 2. Now, if one boy stands, then for those who are sitting, B to G will be girls sitting to boys sitting 9:4. So boys to girls will be 4:9. Now, from here, right, in scenario 1 and scenario 2, in both cases, it doesn't matter boys or girls, but the number of there's only one person standing up in both scenarios, right? So those who are sitting in scenario 1 and scenario 2, the total number must be the same. So the common base is the total. Because in both scenarios, you only have one person standing up. So we make it the same. Change it to 39. So 13, 26, 39. And then this is times 3, which is 12, 27, 39. Now compare, if you compare the number of girls, the number of boys, first scenario, second scenario, how come there are more boys in the first one? Because in the second one of them is standing. Okay, so if you compare the difference in units, right? The difference is 1 unit. And this is because there's one boy standing in scenario 2. So the 1 unit must be 1 boy, 1 person. What is the total in 60? Total 39 units. But your total is 39 only if there is only 1 person standing. There is 1 person standing. Okay, in both scenarios, the total is 39, but there is 1 person standing. So the actual total number of people is actually 39 plus 1. Okay, include the person standing as well. So answer 40 in the class. Part B, after an equal number of girls and boys left for competition, the ratio of girls to boys became 9:2. So find the total number of children who left the class for competition. Now from part A, we know that there are 40 in total, right? But the girls and the boys, how many girls, how many boys at first? So let's do before, change after. The number of girls at first is 26 plus 1. Or we can say 27. Because this one is all of them sitting, right? So girls, 27. The boys will be 13. There's no boys standing in scenario 1. There are 13 boys sitting, so total 13 boys. Okay, then equal number left minus question mark. In the end, 9 to 2. In such a scenario, if you have equal number leaving, right, the difference is unchanged. Okay, the difference remains the same. So let's find the difference in units, which is 7 units. Now let's find the actual difference, which is 27 minus 13. So 7U is 27 minus 13, which is 14. 1 unit is 2. Find the total number of children who left. Okay, we're finding this question mark over here. Let's find 2 units first, boys in the end. Actually, no, we can just find the total in the end, which is 11 units. So the total number of children who left, right, will be the total at first minus total in the end. So answer 18. Okay, question 15. EFGH is a square, FG equals to MG, FG, MG, we have isosceles here. And then we have straight lines, okay, FEL, FEL here is twice of FLE, okay. FLE is 1 unit. FEL is here. That's 2 units. Find FMG, okay, the angle marked out over there. To find FMG, we use the isosceles triangle. Since this is a square, and you cut it diagonally across, it means that this is half of 90. Okay, this is actually 45 degrees. It is half of the right angle. So angle FMG is actually 180 degrees minus 45 degrees. Then you divide by 2. Because these are the 2 base angles that are equal in the isosceles triangle. All right, so this is 67.5 degrees. Next, find GEL. GEL, okay, this angle marked out over here. Now, this is 90 degrees. So I'm looking at this triangle here. Triangle FEL. So we take 90 minus 180 minus the 90 to get the 3 units. Okay, so 3U is 90. 1U is 30 degrees. So this is 30 degrees. Then you find 2 units here. Then next, you need to find out the marked angle. So you take away 45 because FEG is also 45. Okay, half of the right angle. So answer 15 degrees. Next, KJE. KJE, okay, this angle over here. Now, we can find angle KEJ first. So this is 45, right? GEH. Okay, hold on. So this one is 15. Oh, sorry, we missed out another equal side, which is EK and JK. EK, JK, okay. So this is isosceles as well. So to find this angle here, right, it's actually the same as this one. So that's why I'm finding KEH, which is 45 minus 15. KEH is 45 minus 15, which is 30. So this is 30. And it will be the same as KJE, 30 as well. Okay, so angle KJE is also 30 degrees. Question 16, a company offered 150 laptops at a 20% discount during a 5-day sale. So this line graph shows the number of laptops left unsold at the end of each day. Okay, so the number of laptops unsold is actually going down because it means that more and more is being sold each day, right? Okay, so on which day was the most number of laptops sold? You have to read the question carefully. All these are actually end of each day. Now, maybe let's write down all the values first, okay? So the first one is, okay, so one interval, 0 to 20, 1, 2, 3, 4. There are 4 intervals. So every interval is an increment of 5. Okay, 5. First one, 150. Day 2, 135. Sorry, end of day 1, 135. End of day 2 is 90. And this is 40, 20, 20. So which day was the most number sold? Let's look at the decrease. This one minus 15. Minus 45. Minus 50. Minus 20 and minus nothing. Okay, so the greatest decrease is from day 2 to day 3. End of day 2 to end of day 3 means that all these, the sales is being done on day 3. Okay, so answer day 3. Not day 2, but day 3. End of day 3, it recorded sale of 50. So day 3 itself sold 50. Okay, so what percentage of this was sold on the first 2 days? First 2 days, okay, on day 1 sold 15 because at the end of day 1 she dropped by 15. Day 2 is 45, so 15 plus 45. Okay, either 15 plus 45, like the amount sold on day 1 plus the amount sold on day 2, or you can take day 2 minus away the original. Original minus away day 2, end of day 2. So 150 minus 90 also can. Okay, so all. Then that's 2 days, the first 2 days, but what percentage of the total is that? Now, you know, the total is not like you add everything up, no, but the total is 150 as stated in the question, as shown on the graph. 150 is the original. So 60 sold out of 150 times 100%. So that's a 40%. Okay, so 40% was sold on first 2 days. During the sale, the discounted price for laptop was 1288. After the sale, remaining laptops were sold at a discount of 50% instead of 20%. So what was the total amount of money collected from selling all 150 laptops? Now, at the end of day 5, there were 20 laptops left, right? So the 20 is being sold at a discount of 50%. So let's find out what is the price we're talking about. So this 1288 is the discounted price. which is at a discount of 20%. So this 1288 is actually 80% of the original price. And let's find 1%. Which is 1610. Then those that were sold after day 5 were sold at a discount of 50%. So let's find 50%. Which is $805 for each laptop. There were 20 of them. So you see we had 150, right? 150 laptops. 130 was sold at a discount of 80%. And then the remaining 20 was sold at a discount of 50%. So we should take 130 times 1288 is 167440. Then the 20 times 805. Which is 16100. Total amount collected at Denmark. $183,540. Last question, 17. Figure is made up of a rectangle and a semicircle. AEC is a straight line. The arc of a semicircle touches AB. The arc of the semicircle touches AB at point F. Then we have 16 cm and AF equals to FB, okay? Find the area of the semicircle. Okay, area of semicircle, you just apply the formula. Formula for area of circle is pi times radius times radius. So we need radius. (16) divide 2. Then we use the formula half times pi times radius times radius. 100.48 square cm. All right, now for part B, find the difference between the area of X and Y. Now it's a bit hard to find the area of X, to find the area of Y, and then you minus off. Okay, because X is not like, it's not a sector of a circle. You can't find this. Same for Y. Okay, so what we will do is we look for shapes that we can find. So let's name this P, this portion here, P. I can find triangle, which is ADC, which is P and X. Then I can also find P and Y, which is like the boomerang that we have learned before. Okay, square minus quadrant to get P and Y. So if I can find P and Y and P and X, then the difference will actually give me the difference of X and Y. Okay, so I say again, triangle is P and X, right? I can find, this one I can find. I can also find P and Y. So when I find the difference of these two, I end up with a difference of x and y, which is what I want to find. Okay, so let's find these two values. P and X is a triangle. Okay, so P and X. By the way, AD is 8 because radius of the semicircle is 8. So this is radius as well. So this is 8. So half times 16 times 8. P plus X. Okay, P plus X, 64. Now to find P and Y, I will take square minus quadrant. Okay, so square is 64. Quadrant is a quarter times pi times radius times radius. 50.24. So to find P and Y, which is your boomerang, take the square minus the quadrant. So 64 minus 50.24, which is 13.76. Now find the difference, P and X, P and Y. So we take 64 minus 13.76. Okay, so answer 50.24. Square cm. So that is how we find the difference between X and Y without really finding X and Y alone. Okay, so this is the last question. That's all for this is Nanyang 2023 Prelim paper 2.